Hello. Today we are going to talk about graph storage techniques. But before that, let's talk about graph in brief. A graph is a collection of nodes or vertices connected through edges. It is a non-linear data structure. It is used to model paths in a city, social networks, website backlinks, internal network, employee network, etc. A vertex or a node is one fundamental unit entity of which graphs are formed. An edge is uniquely defined by its two endpoints. There are two types of graphs, directed graph and undirected graph. The graph which has directed edges is known as directed graph, and undirected graph is the graph having all the edges as undirected edges. Now we must be thinking, what is directed edges? The edge which is showing only one connection is known as directed edges, and the edge which doesn't show in which direction, that means it is a two-way direction edge, it is called as two-way direction edge, that is undirected edge. So a graph containing all the undirected edges is known as undirected graph, whereas the graph showing directed edges is known as directed graph. Now coming on to representation of graphs, there are most commonly two types of representations for a graph, that is adjacency list and adjacency matrix. There are other representations also, but these are the two main uh, representations which we will discuss. In adjacency list, it will mark the nodes with a list of its neighbors. I will explain it in detail. For example, this is a graph. And let's keep it undirected to make it easy for understanding. So basically what we'll do is that it will create a list of nodes first, and then it will see which node is pointing to which node has edge to other node. That is 0 is pointing to 1 and 2. So it will store 1 and 2. Whereas 1 is pointing to 0, 2 and 3. 0, 2 and 3. Whereas 2 is pointing to 0 and 1. Whereas 3 is pointing to 1 only. Okay, so basically what it does is that it will store in adjacency list. There will be an array which will store list of pointers pointing to this list. So that this is an array and it will store these lists. It will store this lists. These are nothing but linked lists. These are nothing but linked lists. This is also linked list, but it has just one node in it, but still it is a linked list. So adjacency list will store a list of pointers which stores its pointing lists. In adjacency matrix, it will create a matrix which will be storing all the information, and it will store 1 if there is an edge, between I to j or 0 otherwise. So for example, this is 0, like okay. So this is a directed graph, and we will just plot the ones to which if it is connected. Like 0 is connected to 2, so we will just keep 1 in 0 to 2, and same in 1, that 1 is pointing to 2, so it will keep 1. 2 is pointing to 0, 1, 3, so 2 will be pointing to 0, 1 and 3. First we'll plot wherever it is connected, then we'll just simply keep place zeros for the rest. In third, 3 is connected to 2 and 4, so 3 is connected to 2 and 4. 4 is connected to 3, so here I'll write 1. Rest everything will be having 0. So from this, it stores as a matrix so that plotting will be easy. And this is how adjacency matrix works. Now there is another representation known as cost adjacency matrix, which we will see in the next slide. In cost adjacency matrix, the working of this matrix would be same as we have seen in adjacency matrix, but there will be a minor difference, that is, the edges this time in cost adjacency matrix will be having values that will be seen from an example. So this is one directed graph. So this time the edges will be having some values, that is, for example, what if this is one location and this is another location. So to cover this distance, it will take this much time. Such implementations also work through cost adjacency matrix. Okay, so this is our directed graph, and plotting will be done in such way that 0 is now pointing to 2, but instead of writing 1 over here, we will be writing the value of this edge, that is 4. 1 is pointing to 2, so 1 is pointing to 2, but we'll write 8 because the value of that edge is 8. 2 is pointing to 0, 1, 4 and 3, so 4. 3 is pointing to 2, and 4 is pointing to 2. Now, for instance, if 4 was not having If 4 is pointing to 2, but the value of its edge is, let's take for example, as 0. So in this case, we won't be plotting zeros in other cases where the edges are not connected. In those cases, we will be keeping -1. We will be plotting it as -1. If there is no such case as 0, then we will plot as 0 in other cases. That is how adjacency matrix works. Also, there is a representation called as cost adjacency list. Okay, cost in this list, the cost is also stored along with the links. That is two values. Okay, uh, it is not much used normally, but it also depends on your problem definition. So in this example, this is a undirected graph, and over here we'll create one pointer array. And now we used to store in a normal adjacency list, we used to store if 0 is pointing to 1, we will just store 1 as its node's pointer. But instead of that, we will also store its value with it. That is the cost of it. 0 is pointing to 2. So this is how it is written, the pointer and its value. So it is the same as adjacency list. It will create a linked list. Okay, internally it will create linked lists, and adjacency list will store those array, the pointer which will contain pointers of these linked lists with, and in that linked list there will be two values, that is one is the pointer and other the value of it. Okay, so this is how cost adjacency works. There are many other implementations for a graph, but adjacency list, adjacency matrix were the two most commonly used implementations. And there are other implementations too, like edge set. For example, if we take one directed graph, so basically edge set will, what will do is, it will store the pair of its nodes containing to the edge like a set. It will create one set. For example, 0 and 1 it will create. 0 is connected to 4 too, so we'll just create one like this. 0 is connected to 1 and 0 is connected to 4, and 1 is connected to 4. Okay, so this is how edge set works. There is another list called compact list representation, where an entire graph is stored in 1D array. Also, there is cost compact list representation, where the entire graph is maintained in two arrays. Those all implementations do work, but it really depends on what kind of use your problem has. Thank you.